This demo will show how you can build data products using ByteGenie, with an example of building an ETL pipeline. ByteGenie allows you to ingest data from various sources, including manual uploads, cloud object storage, SQL databases, and enterprise systems. Inside the Data Connectors dashboard, you can choose a data source to connect. Fill in the relevant authentication parameters, verify the connection, and save it for reuse. For example, I will save a connection to my Google Cloud Storage named Sample GCS Connection. Inside the Data Upload dashboard, you can manually drag and drop your files and save them as datasets. The Data Upload dashboard will show all your existing dataset IDs. You could either upload a new version of an existing dataset or upload it as a new dataset with a new ID. Once you drag and drop your files and click the Upload File button, the upload will start, and the files will clear once the upload is complete. Once the relevant data connections and uploads are in place, Dataset Builder functionality allows you to build datasets suitable for specific use cases by combining data from across sources. This dashboard will show any manually uploaded datasets and any pre-saved data connections. I can choose any combinations of existing data sources to build and save a new dataset, or a new version of an existing dataset. This allows creating new datasets for specific use cases without duplicating data and retaining full lineage of each dataset to its root sources. Once our datasets are ready, we can head to Model Creation functionality that allows us to learn symbolic models from the data. We first choose a dataset of interest. For this demo, I will choose a portfolio dataset. If I select the dataset and click Show Data, I can see the contents of this data. This data contains information about companies in the portfolio, shareholdings for each company, stock prices, portfolio value by industry, and a schema for portfolio value by industry. After selecting a dataset, we can move on to learning a model. First, we select the type of model to learn. ByteGenie supports various types of models, including ETL pipelines, forecasting models, classification models, and business logic models. I will select the ETL pipeline for this demo. Next, I can select input and output files for model learning. For my portfolio dataset, I will choose company, holdings, and stock prices as input files, and I will choose the schema file for portfolio value by industry as an output file. This will instruct the model to learn a symbolic model to calculate portfolio value by industry, matching the schema. Once the learning configuration is set up, clicking on the Start Learning button will trigger model learning. The Learning Progress module will show logs during the learning. Once the learning process is complete, the model will be ready for use. We can access all available models in the Model Execution dashboard. This dashboard will show all the datasets we have. When we select a dataset, we can see any models linked to that dataset. For example, if I select my portfolio dataset, I see two models linked to it. After selecting a model, I can click on the Show Model button to see the details of this model in the Model Visualization module. This Model Visualization module shows a computation graph of the model, a mathematical representation of the model, and a natural language report explaining the model logic and its inputs and outputs. The computation graph shows the symbolic computations that allow the model to derive the desired outputs from its inputs. If I right-click on one of the computations, I can see more details about that computation, as well as its inputs and outputs. This allows me to get full traceability in terms of how the output was produced and how different computations work. The mathematical representation shows the complete model in a mathematical form. This is useful for understanding the core logic of the model and for reasoning mathematically on this model. The model report summarizes the whole model in a less technical manner, so any user can understand the overall logic of the model. These symbolic models are also executable programs, and you can execute a model on any relevant inputs to generate a new output by clicking on the Execute Model button. When I click on the Execute Model button, it shows me dialog for providing the relevant inputs the model needs. After I select Inputs and click Execute, the model will be executed on these inputs in real time, and the generated output will show up in the Model Visualization module. In addition to viewing the output, you can also validate this output against a ground truth, if it is available, by clicking on Validate Output button and choosing your ground truth output as the target against which to compare the model-generated output against the ground-generated output. Once I select a ground truth output and click the Validate button, the Data Comparison tab will show a value-by-value comparison of the model-generated output against the ground truth and flag any discrepancies in red color, while agreements will be shown in green color. For this portfolio example, we can see that the model-generated agreement is fully aligned with the ground truth. The Validation Summary tab will summarize the findings from evaluation. Once you are happy with an output, you can assign a suitable name to this output and save it permanently into your selected datasets, so it can be reused for any downstream tasks. In addition to generating outputs for a model and reviewing its computation graph, you can also chat with the model in natural language to get a better understanding of the model and the logic it has uncovered. This is particularly useful for use cases which may involve complex logic that you may not already be familiar with. Each chat response will show up inside a dedicated Model Chats module, and you can select any existing chat responses as context to be used for future chats to build smooth, multi-conversation threads. Once you are happy with a model, you can proceed to deploying the model. This can be done under the Deployment Creation dashboard. This dashboard allows selecting a dataset and model of interest, viewing any existing deployments for that model, and creating a new deployment of interest. For example, for my portfolio calculation model, I see an Airflow and an API deployment in place. In the Deployment Config module, I can choose the MCP tool option to create a new deployment for this model as an MCP tool. Once I click Create Deployment, the deployment will be created with the selected configuration. You can monitor your existing deployments in the Deployment Monitoring dashboard, which shows existing deployments for a selected model and allows you to execute a deployment to see its output. In case of Airflow deployments, the deployment will also be accessible on the default Airflow UI running on ByteGenie, with full access to Airflow UI functionality, including monitoring past runs, triggering a run on the fly, etc. One of the key benefits of ByteGenie's symbolic models is that it allows you to perform symbolic reasoning on a model for various downstream tasks in an entirely logical manner, without any risk of hallucinations. One example of this symbolic reasoning is in translating ByteGenie's symbolic models into a programming language of interest. Because of the symbolic nature of the model, it can be translated into any programming language in a fully deterministic manner. This functionality can be accessed in the Model Translations dashboard, which allows selecting a relevant model based on a dataset selection. Once a model is selected, you can choose a programming language of interest, and it will trigger model translation. For example, if I select Python, the symbolic model will be translated into executable Python code, which is logically equivalent to the original mathematical model. I can download the translated code by clicking on the download icon. Similarly, I can translate the model into other programming languages of interest, such as JavaScript, in a fully deterministic manner. Another benefit of symbolic models is that we can derive new relationships and models based on the existing model through purely logical and mathematical reasoning. This functionality is available through the Model Derivations dashboard, which allows selecting a model based on a selected dataset. Once a model is selected, you can ask ByteGenie to derive things from this model. For example, in the case of my portfolio model, I can ask it to derive a relation between industry portfolio return and stock returns. Because this relation can be deduced purely logically, ByteGenie's symbolic reasoning engine will perform the necessary mathematical calculations to derive this relationship. The key derivations will be summarized in Derivation Chats module, and the full set of derivations will be stored as a new model, which can be selected in Derived Models module and inspected similar to any other model. Thus, each derivation will create a new reusable model, which can be used for downstream tasks without any custom development or any new data-driven model learning. Another example of model derivations, I can ask it to find the allocation to the software industry so that the portfolio exposure to this industry is 40%. Again, ByteGenie will solve the original model to derive a relation that allows finding the desired allocation that sets the portfolio exposure to this industry to 40%, and save the derivation steps as a new model, which can be reused across various inputs over time.